Question 59. Solve log dy by dx equal to x plus by. So given dy by dx, log dy by dx is equal to ax plus by. Now therefore we can write, if we take e to the power on both sides, dy by dx becomes e raised to ax plus by. We take e to the power on both sides, that is e raised to, remember, e raised to log f of x equal to f of x. We use this and dy by dx is equal to e raised to x plus by. Therefore we can write e raised to minus by into dy equal to e raised to ax into dx. So we split e raised to ax into e raised to b, this as e raised to x into e raised to by, then we took e raised to by to this side. So this is solvable. This is solvable by the method of separation of variables. So we can integrate both sides. E raised to minus by dy is equal to integral e raised to ax dx plus c. Now here this integral is e raised to minus by by minus b is equal to e raised to ax by a plus c. So this is the solution. There is no other simplification here. So this is the solution to the question number 59. So solving, if anyone has confusion in solving this integral, just remember, if we have a form integral f dash of g of x dx, we can write into g dash of x dx, this becomes f of g of x. So this is a if we have inside the integral this form, we can write this as f of g of x. And note, if g of x, if g dash of x is a constant, and if the integral is of this form, f dash of g of x d of x, and g dash of x is a constant, what we can do is to integrate, we can just divide and multiply f dash of g of x dx, f dash into g dash of x. So we just divided and multiplied this with g dash of x. So now this becomes solvable. It becomes 1 by g dash of x into f of g of x. So here if we see this, if g dash of x is a constant, it essentially looks like integral of this f dash of g of x, which is f of g of x, by g dash of x. So that's what I did here. So here if you see this term is the g of x. It is its differential. Its differential is a constant minus b. So to integrate this, I integrated e raised to minus by, which is ignoring this as ignoring, say, integral of e of u is e of u itself. Integral of e of u du is e of u itself. So integral of e raised to minus by is e raised to minus by, and by here we, so g dash of x terms comes in the denominator, so here minus b divided by minus b. Similarly, e raised to ax by a. This is what we did. So for anyone who has confusion in integrating this is the solution. This is what we do. So it is essentially like dividing minus b and multiplying minus b inside, so we can integrate e raised to minus by, ignoring this b minus by part. So I hope you understood. So that is the solution to question number 59. Now we will do one more question. Solve y minus x dy by dx is equal to a y square plus dy by dx. So we'll write y minus x dy by dx equal to a into, so we will open the bracket, plus a dy by dx. So we will bring dy by dx onto one side. We will get dy by dx into x plus a is equal to y minus ay square. So now we can see easily that this question can be solved using separation of variables, by the method of separation of variables. Y minus ay, all the y terms can be grouped together and x terms can be grouped. So it becomes, if we group, it becomes 1 by y minus ay square. I will take y common. Sorry. 1 minus ay. So let me just write it properly. Dy is equal to 1 by x plus a dx. So we have grouped the terms. Now we can integrate. Before integration, let's simplify this. This is not proper. So to split these terms, we can write numerator as 1 minus ay plus ay. So this becomes 1. So 1 minus ay plus ay into y 1 minus ay dy. Similarly, here we can write, so there is no need. Let this be 1 by x plus a. This becomes log x. So that is why. So here, if we split, we can say see 1 minus ay 1 minus ay into y into 1 minus ay plus ay into y into 1 minus ay. If we split, so this becomes, and if we integrate, now we can integrate. So if we integrate, it becomes 1 by y dy plus y get cancelled, a into integral of 1 minus ay dy is equal to 1 by integral of 1 by x plus a dx plus c. So this becomes log y plus a into, we need so 1 minus ay minus a. So here we will have log 1 minus ay by minus a is equal to log x plus a plus c. So here a and a get cancelled, so we can group. So c, we can this is a constant, so we can for simplicity this becomes log x plus a is equal to, we'll club all this term together, this is minus, so log, so if we write c as, so let me just, we'll take one more step so it will be clear, minus log 1 minus ay. Now here I write c, we take to the other side, minus c, it becomes minus e. Instead of minus e, I am going to write here log c. It is still a constant, log c1, let's call it c1. So it's a different constant, so it doesn't matter. So now if we simplify this, it becomes log, properties of log, we can write cy by 1 minus ay log x plus a equal to log cy by 1 minus ay. So this becomes x plus a, we can take e to the power both side, which gives x plus a is equal to cy by 1 minus ay, or x plus a into 1 minus ay is equal to cy, where c is an arbitrary constant, which is the required solution. This is the solution to question number 60.